Thank you very much, and it's very nice to be back here again, my second year, as was just mentioned. Before I start with my presentation, I'd just like to follow up on a couple of the comments that Jorge was talking about, especially regarding circular economy. This is something that UKBIC, it's not really covered in my presentation, which is why I'm covering it now, something that UKBIC has been very involved in the battery context for the last 3 years. How do you make batteries easy to disassemble? Easy to disassemble, to repair, to put back into their original use. Easy to repair, to second use, to take out of their original purpose where they're no longer fit for function, like an electric vehicle, where you can still use them in an energy storage device. And then at the end of the life, when it's not possible to reuse a battery in any form, in its existing form, you can take it apart. And then you can recycle the parts within it, and you can reuse, and you can regenerate some of the rare earth materials. The cathode active materials can be taken out and recycled and reused. And we've just been doing a project with a UK company called Altilium, where we have successfully coated a 100% recycled cathode active material onto foil, and it's now going through its testing process. So, what's new at UKBIC? And more importantly, why? And if I can just take a couple of minutes to go over what I said last year, because I'm sure that there's some people who didn't hear. UKBIC was created, the idea from UKBIC was created in 2017. Where it was recognised that if the UK was going to meet its targets to take petrol and diesel cars off the road by 2030, we needed to be manufacturing batteries, and the fact of the matter was, we weren't. So the UK government created an organisation, an enterprise called the Faraday Battery Challenge, and gave it a bunch of money to go away and, through the Faraday Institution, to develop advanced lithium-ion materials or products that were going to come after lithium-ion. And secondly, to help to scale those up through running competitions through a UK department that created competitions at different parts of the times of the year, where bigger consortiums could come together and take what was an interesting idea at the Faraday Institution to something that was potentially capable of being made at volume. Then they created UKBIC to be the entity that took that good idea, which customers wanted to buy and potentially investors wanted to invest in, and give them a facility where they could take it from a university pilot line where they were making typically 5, 10, maybe 20 of the products, to an environment where they could make it in the several thousands. So that's where UKBIC comes in. We are the scale-up part of Faraday Battery Challenge, and hopefully at the end of a project with us, and the end of manufacturing with us, they will be able to take their product into a full-scale gigafactory and manufacture at properly industrial scale. So what we have in UKBIC is exactly the same production line that you would find in any gigafactory anywhere in the world. So we have an anode and a cathode line, which can coat and dry at 40 meters a minute. If we ran 24 hours a day, 7 days a week, we could produce 1.5 gigawatt hours of electrode per annum. And then we have cell assembly facilities for producing cylindrical cells and pouch cells. So we can go the whole way through from mixing the powders and the solvents and the binders, coating, drying, slitting, into cell assembly. We have a unique facility. We're in the Midlands, we're based in Coventry, we're right in the heart of the automotive manufacturing sector in the UK. And we're open to all organisations who want to scale technology. Now, this is quite an important part of the presentation, really, because I mentioned right at the beginning, UKBIC was created to protect the UK automotive industry. That has switched because we're not seeing the amount of gigafactories being created in the UK that we thought there would be by now. So we've had to change tack, and we are now a truly global organization, and we will help organizations anywhere in the world who are trying to develop advanced battery manufacturing capabilities. Because although we're not making the batteries in the UK, we are manufacturing the cars and the energy storage devices that need advanced battery technologies. They can't get those from a manufacturer in the UK. We need to be able to get them from elsewhere. And and UKBIC is positioning itself to be able to help companies anywhere in the world. We are a training and learning organization, so we don't really want to make product with people, we want to make product for people. And that means we're a unique capability in that we offer you the opportunity to work with us alongside our engineers, our technicians, to understand how your product is made. And that's not something that you will find in any other manufacturing facility. So, that's back to what I was saying earlier. We are manufacturer at 100 kilogram scale. So you move from laboratory scale to giga scale in one big jump. Now, that's what we thought would work, and frankly, it didn't. What we were finding was that people who were manufacturing at the pilot scale, when they wanted to develop it to a giga scale and came to us saying, we've made our product at a university, now we want to scale it to make 10,000 batteries, we're very quickly finding out the product didn't work. Now, because we're the only organization really in the world that does this, they're having to go away, rework their technology, rework their chemistry, their formulation, their fundamental cell design, and then come back to us and say, we don't need 10,000 cells, we only need 500 because we're still in the development phase. They would have to use us to manufacture those 500 cells, even though it was massively inefficient and created massive amounts of waste by doing so. Because we were really at the sort of TRL 7-8. So we needed to do something about it if we were going to be really industry relevant. So what we've done with additional funding that we got from the UK government, we've installed some new equipment, and that's really what I want to talk about. So the reason why, I've talked about the reasons why, but what we now have is a flexible pilot line which is coming on stream in the next month or so actually now. Middle of August it's going to be online. We're just doing the final pieces of commissioning on it. That will be able to take much smaller amounts of material to push through the line. It operates in the same way as the major industrial scale-up line, but it's at a lower level. It requires less material to prime it, and it takes less material to dial everything in so that we're making good quality cathode and anode. So that's one of the first things that we've been doing. Then once we've done that bit, once you've got that bit right, then you're ready to go onto the major line with a product that you know that will work. So that's a picture of the flexible pilot line. So it has, rather than having separate lines for anode and cathode, it just has one electrode manufacturing line because it's much quicker and easier to clean it down thoroughly between the anode and the cathode. So we don't need both of them. And we can really rent that facility out on a weekly basis, so it'll be much shorter projects that we're working on. And that facility also has within it dry laboratory, which is something I'll come on to in a bit, because one of the things that we also lacked in our original facility was the ability to really characterize cells that we'd made and the electrode that we were making into product that was, so that we knew that the product that we were making was meeting all the production targets and quality targets that it was intended to do. So the flexible pilot line gives us individually controlled zones, like the big line, and it operates in a clean and dry environment down to 40% dew point. And again, it offers our customers the opportunity to get on the line and watch it being made. It's a much more cost-effective way of manufacturing smaller amounts of cells. At the moment, it's an electrode manufacturing facility. It doesn't include cell assembly at the moment, but the government put its hand down the back of the sofa a few months ago, found a few extra euros, so we'll now be able to install new manufacturing lines for cell assembly as well. Now, another thing that industry has been lacking is commercially available clean and dry zones, and that's another thing that we have invested in. So we now have 5 different sized clean and dry zones, because what we'll get finding is a lot of equipment manufacturers, people who are making new notches and stackers, they're manufacturing the product, but they've got nowhere to put it where they can put electrode through it to find out if the equipment works without destroying the material, because it's in a humid environment. So they can bring their equipment, they can bring it to us for a few weeks or a few months while they commission it in a clean and dry environment, and they can know that it's going to work. One thing that we didn't have to do, and now we're coming into the world of subcontract engineering, we were having to send cells that we'd made outside of the business to subcontractors who maybe their quality systems and their performance and their lead times weren't quite as good as we wanted them to be. So we've also invested in more cell cycling equipment, which we've now got in-house. So what we're trying to become really is a one-stop shop for battery manufacturing, all the way from electrode through to cell manufacturing and testing. So the cells that we manufacture are 21700 cylindricals, and they are and 300 by 100 millimeter pouch cells. But in terms of cycling, we can handle anything down to coin cell size. We can handle prismatic cells as well. So we have a very wide range of capabilities now in terms of cell testing. We have our existing formation agent test facilities, which are gigascale formation agent test facilities, but we've now been able to complement those facilities with smaller scale, but cheaper to operate cell cycling equipment, which typically when we cycle cells, we'll be cycling them for between 1 and 6 months. Now, what we've also got is access to now is a battery development lab, which is really industry relevant. Previously, we just had the very basic lab, which was capable of doing performance testing on cells that we'd made. But we now have a comprehensive range of laboratory equipment, which can do full range of characterization, processing, electrochemistry, forensic examination of battery cells. So we can do cell teardowns, which are assisted by the fact that we have a CT scanner on site at UKBIC. So every time we do a cell teardown, we will CT scan it first to look at the best point of entry to make sure that there are no fundamental flaws in the battery which are going to make it dangerous to open. And it enables us to look for the internal structures of the how the electrodes are aligned to make sure there are no short circuits through misalignment. We can look to see if anything's been missed from the assembly process, and we can look for any short circuits in the or potential short circuits. Now, one thing that we don't do, and we still don't do, is we don't do abuse testing. So we don't do nail penetration. So we have to go outside for that. So that's a few images of the battery development lab that we've got. Now, back to a UK perspective, but I think this is the same as anywhere in the world. These are some stats from the Faraday Institution that say in the UK, we're going to need a lot of batteries. By 2030, we're going to need 100 gigawatt hours of batteries. And I'm sure for any country like Bulgaria who is looking to develop battery manufacturing capability, you are going to be, and is also looking at the electrification of vehicles on your roads, there is going to be a massive requirement for batteries. A lot of it's automotive, whether that's passenger car and light vehicle or heavy duty commercial vehicle, but you're also going to need batteries for your energy storage, marine defense applications. So you need to be aware of how you're going to fill that demand for batteries. So in summary, battery technology is developing at an ever-increasing rate. And many of the new entrants to the market have limited funds and materials. And what companies, a few well-known companies and well-known failures are finding that they've tried to scale too big too soon. And they've tried to go for the 10, 20 gigawatt hour facility and then finding out that what they've bought doesn't work. So it's important to take smaller steps to scale up your operations. Organizations seeking to assist these companies, you need to be sourcing the equipment that meets your requirements. Now, I've been talking about UKBIC and how we can help. And yes, I'm here basically to say UKBIC can help you with your battery development process. But what I'd also like to think is that hopefully what I'm saying will guide any of you who are thinking about entry into the battery manufacturing space. This is the type of equipment that you're going to need to invest in to make, to try to guarantee that you've got a product that meets your requirements and is the product that the people that you're selling to actually want to buy. And yes, lastly, as I said, we are a leading independent battery manufacturer. There's nowhere else like us in the world, and we're here to help. Thank you very much.